Hi guys. Today I'm going to talk to you guys about Graham's number. Graham's number is very large and very special. I'm going to show you how we get to it real quick. So first let's get over some notation stuff. So 3 plus 3 plus 3. What is that? Well, it's just 9. That's easy. But we can also write it like 3 times 3, just like that. Let's take this a little bit further. What is 3 times 3 times 3? Well, that's 27. Also pretty easy. And we can write that as 3 cubed, 3 to the 3. Now there's actually another way to notate exponentials, and it's using arrows, like this. So 3 arrow 3 is the same thing as 3 to the third. And the good thing about arrows is we can actually do multiple. So we could do 3 arrow arrow 3. Now what would this be? Well, that's the same thing as 3 arrow 3 arrow 3, which we can simplify this down a little bit, and that would be 3 arrow 27, since we just found 3 arrow 3 is 27. And what this would be is, of course, just 3 to the 27, which is a gigantic number. It's about 7.6 trillion, so stupendously large. And you're going to see things are about to get out of hand very quickly. Let's try 3 arrows. How big of a number would this be? Well, if you were to simplify everything down, what you'd end up finding is that it's a stack of 3s, like 3 to the 3 to the 3 to the 3, and that stack of 3s is 7.6 trillion 3s high. So, gigantic number. I mean, this is not something that we could ever really conceive of. It's so gigantic, but we're still not even close to Graham's number. And the way that we get to Graham's number is we first define G1, which we can say G1 is 3, let me get this right, 3 arrow, 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 arrow 3, which we already saw the last one with 3 arrows was gigantic. This is even more gigantic. You can't really even write it down. I'm just going to leave it like that. This is some inconceivably enormous number. Next, we're going to define G2, which is 3 arrow, arrow, and then many, many arrows, and then 3. And the amount of arrows in between is equal to G1. We have G1 arrows in this number. So this is inconceivably more large than the last one. And we can keep doing this. So we can say G3 is arrow, arrow, dot, 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 arrow, 3, and give it G2 arrows. So even larger. These are not numbers that you can conceive in any way. And if you do this enough, we get to Graham's number, which is not G4. Graham's number is G64, which we could write as 3 arrow, arrow, arrow 3, and there's G to the 63 arrows in between the two 3s. And this is Graham's number. Graham's number is enormous, like inconceivably enormous, literally. If you tried to picture Graham's number in your brain, there would be so many digits in such a small, area that there would be enough entropy to collapse your head into a black hole. That's how big of a number Graham's number is. It's not something we can write down. It's not something we can even really think about very well. Now, it does have some applications in graph theory. There's some problems there. I'm not going to get into them here. It does have a use. I just think this is a very interesting number. So thank you for watching this video about it.